So let's imagine that the potential now is 0 everywhere until we get to x equals 0, and then it jumps to some value. X equals L looks like that. But we're in a situation where the energy, say, looks like that. What kinds of solutions do we have? In this case, right, in region 1, 2, and 3, the difference between energy and potential has a different sign here compared to here. So in region 1 here, we have an A e to the I kx plus B e to the minus I kx, where k is, right, there's no potential there, potential 0, so k just looks like that. In region 2, we have a C e to the minus alpha x, right, so that's a real coefficient, plus D e to the alpha x, where alpha is now 2m v naught, let's call this, let's say this is, so the value, this is v, and this here is v naught, and so we can call that v naught minus e over h bar squared. Notice that we can't get rid of the exponential growth because we have no problem with normalization, because it's a finite region of exponential growth, so that solution has to be there as well. We can't eliminate it. And then in region 3, we have this asymmetry. We see dE. We again have an e to the I kx solution. So similar to the previous situation, except for this region here where that sign has changed, and we have a real coefficient there in the exponents. But similarly to the previous problem with the finite well, notice that these kinds of things in region 1 and in region 3, they can't be normalized, right? Because we're going from L to infinity and from minus infinity to 0 with this kind of thing. And as we saw at the beginning of the course, right, this psi3 modulo squared is E modulo squared. That's some constant, and we integrate that over an infinite region, we get infinity. And so we can't normalize that. So the reality is that physical solutions associated with this kind of potential and the finite potential of the previous problem involves combinations of these kinds of solutions, right? So it's continuous superpositions of these kinds of solutions where the energy can take on different values.